Hi there. We are Team 35 of CS640 6440. We have implemented a tool called Disease Vision that we are going to talk about today.
I'm Colin. This is my seventh class of the OMSCS program. I'm a full stack software engineer, and I mainly focused on the front end portion of this project.
And I'm Clint. This is my final class in the OMSCS program. Super excited to graduate. I am a software engineer, sort of focusing in the DevOps space. And for this project, I worked primarily on the back end.
Our inspiration for this project was really all about the individual, right? So for a patient, we want to know their risk for um, getting a disease, really. But that's really hard to find, right? You have all this data that's out there, all of this data from a bunch of different resources, whether it be the government, independent resources. But it's really hard to find, parse, go through, interpret this data. And we really wanted to provide a way to finally go through and determine the risk of developing not only a single disease, but many diseases. So what we did was we developed Disease Vision, and it's a web-based tool for translating the demographics of an individual patient, which we determine from age, gender, race, and the location or the state in this case, into the disease risks from the data set that we were dealing with, which was handling population death rates for the 113 most common causes of death over a 10-year range from 2011 to 2020. And we got that data from CDC Wonder, where you're able to go in and sort of nail down what variables you would like your data partitioned by. And so we were able to go in with our demographics, age, gender, race, and state, and get the data set that we needed to.
So as far as our project's implementation status is concerned, so the main components of our application are a front-end app that runs in the browser. That front-end app integrates with FHIR, so we are querying for patients from the Happy FHIR test server. That's where we get the patient demographics from. We then make a call to a backend server, which we developed with those demographics. And that backend will then query a database, which we populated with the data from CDC Wonder. So we inserted the data from the CDC into this database so that we can query based upon those demographic properties. The backend, upon receiving this list of causes of death with their relative death rate for each of these diseases, we sort them so that we get the most common causes of death. And then for the 5 most common causes of death, we will send those diseases to a generative AI model, which will then generate a summary of that disease, which will include a description of the disease, some of the risk factors of that disease, and also what preventative measures a person can take to help mitigate or prevent the disease. And then once the backend has performed those actions, it will return those sorted summaries to the front end, which then displays them to the user, so that the patient has basically a plan. Like it's kind of a plan for them to follow to help decrease their risk of developing those diseases. And we like to point out that all of the components that we planned on implementing, we actually were able to implement as part of the project. So here's just a quick little diagram of the architecture of our of our application. Here's the front end. It gets those demographics from the Fire server. It makes the call to the backend, which then gets those causes of death from the public data sets in our database, and then sends those over to get summaries generated by the generative AI, and then sends those back to our front end. So as for what areas we researched, first we wanted to know if there was similar tooling available that did this thing that we're trying to do. And what we found was that most tools focused on a single disease or on a small group of diseases and not on large panels of disease. And that is detailed in that paper by Bognolo. And we also wanted to know what data sets were available that we could use to power our tool. And so we found that there were a lot of data sets that could potentially be used, but again, we're primarily focused on single diseases. And then we came across CDC Wonder, which is a portal from the Centers for Disease Control and Prevention that allows you to query several different data sets, including one called the 13 most common causes of death. And it was the most comprehensive data set that we found and was perfect for our purposes. And so that is the data set that we ended up going with.
So going through the research process and the implementation process as well, we had a few challenges. One of those was just dealing with the Happy Fire data. So interacting with the server, having the data come back, analyzing the data, seeing if that data would suffice for what we were looking for. So really, we were looking for patients that had the right demographics that we needed for our analysis, being race, age, gender, location, specifically state. And so it's a challenge in itself to find patients that have all of those values inside of Happy Fire, and then let alone like take race, for instance, like we see in the pictures down below. These extensions on these two different patients have the same extension, the US core race extension, but when you go to actually try to grab that data, like let's say we're trying to grab the race code off of it, how you access that data is different. It's not always consistent. So trying to find a generic adapter or a solution to grab that race code, to grab the display of that race, is different. Like on the left, you would have to go into extension, then go into value codable concept, then go into coding. While on the right, you have to go into extension, then extension again, then value coding. So it's just different ways to access the same data, not always consistent. So that was the challenge.
Okay, we're ready for our demo. So I will pull up the website. So this is a publicly available website. We registered a domain name for it and everything. This is hosted in AWS. So here's sort of the main page that you go to when you go to diseasevision.com. We've implemented just a sort of placeholder authentication system. This authentication would be a provider would use their login, right? Logging into, say, an EHR or something. So we just have this static password that we use to log in, CS6440. And upon logging in, the provider would see a list of patients that, so their patients, presumably, they could then generate these summaries for. So these are some patients that we were able to source out of Happy Fire. So let me just open up this debug panel here so we can see the network requests. When I click on one of these patients, it will actually make a query to Happy Fire, and we'll be able to see that right here. This is the request to Happy. You can see here's a Fire encoded resource, and we have demographics like their race, and somewhere in here there will be their age and other demographic information that we can see populated right here. And as you saw here, we were waiting on a request, which was this request right here, this disease risk request. This is the request which took this demographic information and sent it to our backend. And here's the payload. And in response, the backend sent a list of summaries, which is ordered based upon the relative risk. So this acute myocardial infarction is the highest risk for this particular demographic group. And here you can read, it's a human readable summary of this disease, and also the particular risk factors for that disease, and some preventative measures that can be taken to mitigate that disease. And here are the top 5. Some patients, based upon their demographic group, may not have a full list of 5 just because of lack of data. But we display the top N that they have available, or if there happens to be no results available for that particular group, we ask the generative AI to create a disease risk summary for that a patient with those demographics. So that's the functionality of the app, which is available for anybody to actually play around with, and is something that allows us to generate these summaries, which are intended to be consumed by the patient themselves in being able to assess their risks for diseases that may affect them in the future, and what they can do now to prevent those diseases. Okay, so as far as future work is concerned, we're very happy with the data that we were able to source. We did have to do some additional filtering on it. We found that there were sort of, even with the limited set of 113 causes of death, there were some duplicates, as in, like, we had more specific like subsets of diseases included that we had to sort of aggregate together. So additional filtering and deduplication of that data would likely result in better quality results, including, selecting a more narrow list of causes of death. And then, of course, we could also improve the AI generation by some prompt engineering. And of course, the UI can be improved by integrating more tightly with like an EHR, providing authentication through Smart on Fire, and also allowing this to be more patient-centric, right? There's no reason why this couldn't be something that could be accessed through the patient portal of an EHR, and a person themselves could request this information for their own benefit, rather than needing to rely on a provider. And that is our presentation. Thank you very much for listening.